All right, guys, today we're going to be learning about linear inequalities and systems of linear inequalities. So to get started, we're going to, of course, learn about what a linear inequality is. And we're going to do some practice, and then we're going to practice with systems of inequalities. So a linear inequality is similar to a linear equation, but it uses an inequality symbol. Right, which is less than, greater than or equal to, less than or equal to. Those are inequality symbols. So the solution to a linear inequality is all the ordered pairs that make the inequality true. Okay, so the solution to the linear inequality is all the ordered pairs that make the inequality true. So to give you an example, we have to determine which ordered pairs are solutions to the linear inequality below. So looking at all of these solution sets that they provided to us, which one is going to make this equation right here true? Well, that's really easy to figure out because I have an x right here and I have a y right here. So I'm going to take that x and that y, and I'm going to use the x and the y that they gave me in the ordered pair, and I just have to plug it in, and see if it's a true statement. So again, my x and y are my ordered pairs, so I'm just going to fill that in. So I'm going to have 2 multiplied by 2 minus 3 multiplied by 5 is that less than 15. Okay, well, 2 times 2 is 4. Negative 3 times 5 is a negative 15. Is that less than 15? Well, 4 minus 15 is going to give me a negative 11. And that is less than 15. So because that's true, it is a solution. Okay, we are looking for true statements. So that means that yes, this is a solution to that inequality. Okay. Now again, we have another ordered pair, and we're going to use our x and our y values. We're going to plug those into the equation. 2x minus 3y is less than 15 to see if it's a true statement. Okay, so 2 multiplied by negative 1 minus 3 multiplied by a negative 7, is that less than 15? Well, 2 times negative 1 is a negative 2. Negative 3 times negative 7 is a positive 21. Is that less than 15? Well, negative 2 plus 21 is going to give me 19. Is 19 less than 15? That is false. So that is not a solution to this problem. It is a false statement, so it is not a solution. Okay? No. And then we have 3 and negative 4. Again, I'm going to take my x value and my y value, and I'm going to plug it in for my x and y variables in the equation. So instead of 2x, I'm going to have 2 multiplied by 3 minus 3 multiplied by negative 4. Is that less than 15? Well, 2 times 3 is 6. Negative 3 times negative 4 is a positive 12. Is that less than 15? Well, 6 plus 12 is 18. Is that less than 15? No, it is another false statement, so it is not true. It is not a solution to the problem. Okay? Again, not true. Finally, we have the ordered pair 0, 0. So that's our origin. Is this ordered pair 0, 0 a solution to this inequality? So I'm going to plug in those zeros. So I'm going to have 2 multiplied by 0 minus 3 multiplied by 0. Is that less than 15? Well, 0 times 2 is 0. Negative 3 times 0 is 0. Is that less than 15? Well, yes, 0 is less than 15. It is a true statement. So it is an answer to this inequality. True. If you see a question like this on the test, that's all you have to do is you just have to plug in those x and y values that they gave you in the ordered pair and plug them into the equation to see if you get a true statement. Okay? All right. So when we are graphing linear inequalities, it is a way to show all of the ordered pairs that are the solutions. So that's why we graph, because then we can see all of the ordered pairs that are solutions to the graph. So to do this, to graph a linear inequality, we have to put the inequality in slope-intercept form. Okay, and we have to remember to flip the inequality symbol if you multiply or divide by a negative number. So if we multiply or divide by a negative number, we have to flip the sign. Do not forget. Okay? So when you graph the line, you will use a solid line for a greater than or equals to or a less than or equals to symbol. Okay? So if you have a solid line, that's when you have a greater than or equal to or a less than or equal to. Okay? If you will use a dotted line, for a greater than symbol or a less than symbol. So that's when you do not have the equal sign. That's when you use a dotted line. Okay? So solid line looks like that. Dotted line looks like that. Those are the two different types of lines that you will have when you are graphing a linear inequality. Now when it comes to the shading, you are going to shade above the line for a greater than or equals to symbol. Okay, so if the variable is greater than, then you are going to shade above the line. Now, if you have shading below the line, okay, when you shade below the line, that's when you have a less than or equal to symbol. And that makes sense, because if it's less than something, then you should be shading below the line, okay? So let's practice with this example here. Okay, so we have 2x minus 3y is less than 15. So the first thing we need to do is write this in slope-intercept form. So that's our first step, is to rewrite it in slope-intercept form. So to rearrange this, I first have to subtract 2x from both sides. So then I'm going to have negative 3y is less than negative 2x plus 15. Then I have to divide by negative 3, divide by negative 3, and divide by negative 3 so I can isolate that y. So y is now going to be greater than, because I divided by a negative, I have to flip the sign. Okay? It's going to be greater than 2/3 x minus 5. Okay? So I did not forget to flip the sign because I divided by a negative number. Okay? Now that I have my equation in slope-intercept form, now I need to identify all of my key attributes. So I have y is less than, it's not equal to, so I'm going to have a dotted line. Okay, and it's going to be shaded, or it says y is greater than, sorry, y is greater than 2/3 x, so it's going to be above, we're going to shade above the line. Okay, so we're just looking at our inequality symbol, and that's going to tell us whether we have a dotted or solid line, and if we're shading above or below. And so we are going to shade above. Then we need to identify our slope. Oops. And our slope for this line is right here. This is always going to be our slope. So our slope is equal to 2/3. So it's a positive 2/3, so I can either go up and to the right, or 2/3, a positive 2/3 can also be down and to the left, because it would be a negative divided by a negative, which also gives me a positive. So either one, either direction works. Okay, and my y-intercept here is equal to this -5, because that constant, that number on its own, is always going to be equal to my y-intercept. So that's going to be the first line that the first point I put on my graph will be -5, 0. I mean 0, -5. Okay, my y-intercept is always where my x is 0. So 0, -5. Now I have to find my slope. So I'm going to go up 1, 2, and to the right 3. So I went up 2, and I'm going to go to the right 3. And I have my point. And if I went up 2 and to the right 3, then I would have my other point. Now I connect the dots with my dotted line. Okay, it's not a very good line, but that's okay. My dotted line, and I have graphed this inequality, except for I haven't shaded yet. And so remember that we are shading above the line, so everything up here would need to be shaded in. Okay, because we are shading above the line. All right, so that's how you graph a linear inequality. Now we're going to practice graphing systems of linear inequalities. Okay, so a system of linear inequalities is when you have two or more linear inequalities. that are graphed together. Okay, so again, the solution to a system of linear inequalities is going to be the overlapping region so it's where the overlapping region of points that satisfy both inequalities. And that's when you satisfy both. So it's the overlapping area. So you have to be able to graph both equations and then see where the two areas overlap. Okay, so we have two equations here. So this is a systems. We need to graph each system of linear equalities to show all of the possible solutions. So y is greater than negative x minus 1. So I'm going to look at this linear inequality first. So y is greater than negative x minus 1. Now let's pull out all of the information that's been provided to us here. So y is going to be greater than, and it's a dotted line, okay, because it doesn't have the equal sign, so it will be dotted. And it is greater than, so it's going to be shaded above the line, okay? Now what is the slope for this line? Well, it says negative x, so that means that my slope is going to be negative 1 over 1. So that would be down 1 and to the right 1. Or negative 1 can also be a positive 1 over a negative 1, which would be up 1 and to the left 1. Both of these would work as far as following your slope for this line, because they mean the same thing. Our y-intercept for this line is negative 1, okay? So this here, this negative 1 is my y-intercept. That constant is always going to be my y-intercept, as long as I'm in slope-intercept form. So I'm going to graph this line, and I'm going to graph it in pink. And remember that we're going above. So I'm going to start at my y-intercept, which is negative 1. So I'm going to start by putting a line, a point right here. Okay. And it says that my slope is negative 1 over 1. So I zoomed in so that you can see it really well. So negative 1, I'm going to go down 1 and to the right 1. Down 1 and to the right 1. Down 1 and to the right 1. You get the idea. Okay, we're just going to keep going. We can also go up 1 and to the left 1. Up 1 and to the left 1. Okay, and since we have a dotted line, I'm just going to connect every other point. So I have a nice clean dotted line, and I can do it in the other direction as well. Okay, so this is my first inequality, and I would be shading above the line, right? This is the area that we would need to shade for this inequality. All right, now let's start graphing our other linear inequality. Okay, so first we're going to look at the symbol, and the symbol is less than, and it's not equal, so it's also going to be a dotted line. But now, since it's less than, it's going to be shaded below the line. Okay, so it's going to be a dotted line shaded below. The slope for this line is equal to 1 over 1, because 1 is just up 1 over 1. So that can be up 1 and to the right 1. Or it can be -1 over -1, because that would still give me a positive number. So that could be down 1 and to the left 1. Okay, so that is my slope. And my y-intercept is equal to 5 here. Okay, because right here is my constant, so that is my y-intercept, -5. So now I'm going to go to my graph, and I'm going to graph this in purple. Okay, so y is less than -x minus 5. To graph that, I'm going to go down to -5. And again, I'm going to zoom in just a little bit more so you can see it better. So 1, 2, 3, 4, 5. I'm going to put my first point. Now I need to follow my slope, and my slope is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, and so on. And I can go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. As long as you have enough points to connect, that's good. Or if you have a ruler, you can do it that way. Okay. So this is my second line, and it says I am shading below. So this is the area that I need to shade. And so my solution for this system is going to be everything that's in this dark blue area. Okay? The solution to this systems equals the dark blue, because that is where they overlap. Okay? That is where they overlap. So that would be a solution. All of those ordered pairs would be solutions to both equations. Okay? So we're going to do another example problem here. So we have y is less than 1/3 x plus 7. So I'm going to pull that equation over here so I can pull out all the important parts. So y is less than 1/3 x plus 7. That's a less than symbol, not equal to, so it will be a dotted line. And because it's less than, it will be below. Okay, so we have a dotted line, and we will be shading below the line once we graph it. The slope for this line is equal to 1/3. It's a positive 1/3, so we can go up and to the right, or it can be -1 over -3, which would be down and to the left. Okay, our y-intercept here is equal to 7. Okay, because of that positive 7, that constant that's on its own in slope-intercept form, that tells me my y-intercept. So because this one is shading below, I'm going to go ahead and graph this in my blue pen. Okay. So the first place I'm going to start is I'm going to go to my y-intercept, which is positive 7. So I'm going to go to 0, 7, and I will zoom in. Okay. 1, 2, 3, 4, 5, 6, 7, and there is my point. Now I need to follow my slope. So I'm going to go up 1 and to the right 3. 1, 2, 3. Up 1 and to the right 3. 1, 2, 3. I can also go down 1 and to the left 3. 1, 2, 3. Oops, kind of moved. Down 1 to the right, to the left 3. 1, 2, 3. Okay, I have a dotted line. So just like that is fine. And for this line, I am shading below. So this area, and I need to shade it. I'm going to shade it in the blue. So all of these ordered pairs below that line would be solutions to this inequality, okay? So now let's look at our second equation. So we have y is greater than or equal to, well, a greater than or equal to will be a solid line, okay? So we now have our solid line, and it says greater than or equal to, so it's going to be above. So we will be shading above the solid line. Our slope, here -1x, so it would be -1/1, or it could be 1/-1. They would both give me the same slope. So -1/1 is down 1 to the right 1. This would be up 1 and to the left 1. Okay, just make sure you understand how to follow the slope. And the y-intercept here is equal to 4. That constant number is my y-intercept. So that's going to be the first graph, the first point I'm going to graph on this line. And I'm going to use pink to graph this line because I'm going above. Okay, so let's start at 4. 1, 2, 3, 4, and I'm going to put my point. My slope is -1/1. So I'm going to go down 1 and to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. I can also go up 1 and to the left, up to the left, up to the left, okay? This is a solid line this time. So there is my solid line, and I am shading above. So this direction, I put the arrows there to help me so I don't forget. And all of the solutions would be right here for that linear inequalities. So the solution to both, again, is going to be this area where they overlap. Okay, that area where they overlap is the solution to both systems. So the solution is the overlapping area. Okay, we have one more example to go through, and I'm going to try to get through this really quick because I'm running out of time. So this first equation here was not given to us in y-intercept form. So that's our first step, is to rewrite it in slope-intercept form. So to do that, I need to subtract x from both sides. So I'm going to have -4y is less than or equal to -x plus 24. And then I need to get rid of that -4, so I'm going to divide by -4. And when I divide by a negative number, I have to flip the sign. So I'm going to be left with y is greater than or equal to a 1/4 x, and that will be -6. Okay, so I didn't forget to flip the sign. And now I'm going to identify all my important parts. So this is y is greater than or equal to, so it will be a solid line. And greater than means I will be shading above. Okay, my slope here is 1/4. So that's going to be up 1 and to the right 4, or -1 over -4, and that would be, sorry, down and to, So -1 would be down and -4 would be to the left. Okay. So my y-intercept here, I already highlighted. My y-intercept is equal to -6. So I'm going to start graphing this line. And because I'm going above, this is going to be my pink line. Okay. So my y-intercept is -6. So I'm going to go down to -6 and graph my point. 1, 2, 3, 4, 5, 6. And put my point. My slope is 1/4, so it's up 1 and over 4. 1, 2, 3, 4. Up 1 and over 4. 1, 2, 3, 4. And I can also go down 1 and to the left 4. 1, 2, 3, 4. Okay, this is a solid line. And I am shading above. So there you go. Okay, now we're going to look at this other equation, which is already in y-intercept form. This is saying it is y is less than or equal to, so it's also a solid line. And it's going to be going below because it's less than, so it will be going shaded below the line. Okay. My slope here is equal to 2 over 1 or -2 over -1. Both would give me a +2 slope, and my y-intercept is equal to +1. So I'm going to graph that line. I'm going to graph it in blue for this linear inequality. So I'm going to start at my y-intercept of 1. And my slope, +2 over 1, so up 1, 2 over 1, up 2 over 1, up 2 over 1. I can also go down 2 into the left 1, down 2 into the left 1, down 2. And so I'm going to draw my solid line like so. And I will be shading below the line. And so it would look like this. All of these this area would be the solution to that linear inequality. So the solution to both is going to just be this area here in dark blue. All right, guys, that is it for our notes today. I hope you finish your notes, get them written in your interactive notebook, and turn them in. Have a great day.